In this video, we'll learn how to estimate the cost of debt using the term structure of interest rate approach. The term structure of interest rate approach compares time to maturity with the percentage yield or yield to maturity for each bond. To find this information, we have to go to FINRA's website. Now I'm gonna switch screen to FINRA. FINRA is the financial regulator for the bond market, and they have the most comprehensive bond trading records for all the bonds in the United States. They also publish the most updated bond information through their website. To access the bond information, go to FINRA's market data page, and then in the quick search section, type under symbol and CUSIP, type the company's ticker symbol. For example, Caterpillar's ticker symbol is simply CAT, and make sure that the setting is set to bonds, and then just press enter on your keyboard, and that will pull out all the current outstanding bonds for Caterpillar. Unfortunately, unlike the SEC Edgar's database, FINRA doesn't allow you to automatically download this information. So what you have to do is to manually scrape this information into Excel. So let's see what information they publish. They have the issuer name, the symbol for each bond issuance, whether this bond is callable or not, and the subtype of bond. They are all corporate bonds. And what is the coupon information, maturity date, and the rating information based on the Moody's and S&P rating for each of the bond. And then the last column give you what is the price of the bond and what is the yield of the bond. So to estimate the term structure of interest rate, we need to know what is the percentage yield, which is just the yield divided by 100. And we also need to know what is time to maturity. Since we have the maturity date, so the time to maturity is basically how many calendar days between the valuation date and the maturity date. So this page gives us all the information we need. So the next task is to simply just copy over all the information manually to an Excel work file, and then do a lot of formatting in order to get the complete information necessary to estimate term structure of interest rate. Be aware that some of the companies that you estimate might not have a very large number of bonds outstanding. For example, tech companies, in which case you have to resort to CompuStat rating database to find what are the companies that issue bonds similar, that's identical to the rating of the bond that you're interested in. In this case, for Caterpillar, we're interested in A rating bonds based on S&P rating. So you go to CompuStat database to pull out all the A rating bonds in order to get roughly 100 issues of bond in your bond database. You can refer to the top hat page for more detailed information on how to download data from CompuStat's rating database. Anyway, now we put together this information. We can copy them to our Excel worksheet. And then afterwards, after a little formatting, we have the database ready to go. What we're interested in is the bond life and percentage yield. So the bond life is essentially number of calendar days between maturity date and the estimation valuation date. The valuation date for this exercise is the first day of 2012. So you enter the first trading day of 2012 and compute how many calendar days between this date and the maturity date. And then the result give us 7,820 days between those two calendar dates. And the yield, percentage yield is essentially the yield information for each bond divided by 100. And now you computed those two columns. The next task is to estimate what is the yield corresponding to the bond life using a trend line on the scatter plot between those two variables. So you plot those two columns, and then using a scatter plot, and then then you will use a polynomial fit to fit the scatter plot, because the relationship between those two variables are no longer linear. So you will try to fit a polynomial fit based on those, you know, that best fit those two variables, and then come up with the estimation equation for this relationship given by this equation here. And you can try to play with the order number for this polynomial fit between 2 to 3 to see which one seems to fit the underlying data better, and then stick with that order number. Okay, in this case, I come up with the estimated relationship for the term structure of interest rate here. And the next step is trying to find a value for X. X is the bond life. So the next step is trying to see what is the average measure for bond life, and what is the median estimate for bond life. The average estimate for bond life can be calculated using the average function on the bond life, and the median is simply calculated using the median function on bond life. So once you have an estimate for X, then you will plug in X into this estimated equation here to compute what is the estimated Y. Estimated Y here is what is the estimated yield to maturity based on all the bonds outstanding for this company. So in this case, the yield corresponding to average maturity is 3.77, and the yield corresponding to median maturity is 3.34. So you have to use your best judgment call to see which yield measure you want to use in order to be the ultimate proxy for cost of debt. So in this case, I chose the higher yield because I believe that, you know, Caterpillar during this time horizon is slightly riskier in corporate financial crisis. So I arbitrarily chose the higher yield, and this is my ultimate proxy for cost of debt going into my Y calculation.